How to choose a suitable motor-operated valve. Motor-operated valves are an indispensable part of industrial automation control systems, playing an important role in regulating and controlling systems in pipelines and equipment. In pipeline engineering, the correct selection of motor-operated valves is one of the guarantee conditions to meet on-site usage requirements. If the selection of the motor-operated valve used is improper, it will not only affect the use, but also bring adverse consequences and even serious losses. So, choosing the right motor-operated valve is very important. What is a motor-operated valve? Simply put, a motor-operated valve is driven and controlled by an electric actuator, which can achieve the opening, closing, and adjustment of the valve. Motor-operated valves mainly consist of electric actuators and valves. Motor-operated valves are high-end products in the field of self-control valves. They not only have the function of opening and closing, but also have the function of adjusting valve position. By using a part-turn electric actuator in conjunction with a valve with angular stroke, the valve can rotate within 90 degrees to control the fluid in the pipeline. A linear electric actuator is used in conjunction with a linear stroke valve to achieve upward and downward movement of the valve plate, and control the fluid in the pipeline. Technical principles. Motor-operated valves are usually matched with electric actuators and valves, and become motor-operated valves after installation and debugging. Motor-operated valves use electricity as power to connect the electric actuator to drive the valve, achieving valve opening and closing, adjustment actions, so as to achieve the purpose of on-off or regulating control of the pipeline medium. Functional requirements for motor-operated valves. According to engineering control requirements, the control function of motor-operated valves is completed by electric actuators. The purpose of using motor-operated valves is to achieve non-manual electrical or computer control of the valve's opening, closing, and adjustment linkage. The current use of electric actuators is no longer just about saving manpower. Due to significant differences in the functionality and quality of products from different manufacturers, choosing electric actuators and valves is equally important for engineering. Electric actuators are essential equipment for valve programming, self-control, and remote control, and their motion process can be controlled by the magnitude of stroke, torque, or axial thrust. The working characteristics and utilization of electric actuators depend on the type of valve, working specifications, and the position of the valve on the pipeline or equipment. Therefore, the correct selection of electric actuators is crucial to prevent overloading, working torque higher than control torque. When choosing a motor-operated valve, attention should be paid to the following points. The operating torque is the most important parameter for selecting an electric actuator, and the output torque of the electric actuator should be 1.2 to 1.5 times the safe torque for valve operation. There are two main structures for linear electric actuators. One is to output torque directly without a thrust disc. Another approach is to configure a thrust disc, where the output torque is converted into output thrust through the valve stem nut in the thrust disc. When selecting an electric actuator, it is important to clarify whether the actuator body needs to withstand thrust. The number of rotations of the output shaft of the electric actuator is related to the nominal diameter of the valve, the pitch of the valve stem, and the number of thread heads. It should be calculated according to M equals HZS. M is the total number of rotations that the electric device should meet, H is the valve opening height, S is the thread pitch of the valve stem transmission thread, and Z is the number of valve stem thread heads. If the maximum allowable valve stem diameter of the electric actuator cannot pass through the valve stem of the matched valve, it cannot be assembled into an motor-operated valve. Therefore, the inner diameter of the hollow output shaft of the electric actuator must be greater than the outer diameter of the stem of the rising stem valve. For part-turn valves and non-rising stem valves in multi-turn valves, Although the diameter of the valve stem does not need to be considered when selecting, the size of the valve stem diameter and keyway should also be fully considered to ensure normal operation after assembly. Appropriate output speed. If the opening and closing speed of the valve is too fast, it is prone to water hammer phenomenon. Therefore, the appropriate opening and closing speed should be selected according to different usage conditions. Electric actuators must have torque or thrust, protection function, which means they must be able to limit torque or axial force.
Hankun quality driving the future.